Fitting data. So we need to fit data when we're given or got to establish this relationship when we're given a table of values. Now, we need to work out first if it's going to be direct variation or inversely. Now, if we look at B here, the B values go up. And what happens to A? Well, they also go up. So when they go up, both of them go up, then this is going to be a direct variation. So what we do, we've given A and B. We'll say, right, A is proportional to B. Now it's proportional to B in some way, we don't know what it is, so we'll just write A is proportional to B to the power of n. And therefore our rule is A equals KBN. Now, we've got to choose a value of n, and then we will work each point out. And if we keep getting the same answer, that means that's our K. So I'm going to use n equal to 1. I'll rearrange this one and have K equals A divided by B to the power of n. So if n equals 1, don't use 0, 0 because that's going to work out. That will give you 0. We end up getting K equals, our A is 12, our B is 2, and I've got to the power of 1. I'm not even going to write it. So that will equal 6. Using the other point, that was the point 2 and 12. I will use the other point, 4 and 48. 4 and 48 gives us K equals 48 divided by 4 to the power of 1, which is still 4, so K equals 6. I'll use the other point, 6 and 108. So K ends up being 108 divided by 6, which means that's 6. And the last point, 192, I'm writing in the wrong order, but I'm putting them in right at 8. K equals 192 divided by 8, which means K, oh, that's not 6, that's 12 there, sorry. Oops. This one is 18, and this one ends up being 24. I suppose I didn't really need to check, because when n equals 1, it doesn't work. So I'll do n equals to 2 here. K will equal, well, the first point is A is 12 and B is 2. So I get 12 divided by 2 squared, which means it's 12 divided by 4, which means it's 3. The next point, 48 and 4. I'll try and write them all in the correct order this time. I get 48 divided by 4 squared, which equals 48 divided by 16, which means K equals 3. The next one's 108 and 6, so K will equal 108. 6 squared is 36, and that one equals 3. And the last one, 192 and 8, so I get K equals 192 divided by 8 squared, which is 64, and 192 divided by 64 equals 3. So therefore, since all these quotients are the same, that I have worked out my K. See, on the other side, I had 6, 12, 18, and 24 all different. So how can K be all different? So I have K equal to 3, and I had let my n equal to 2. So n equals to 2. Therefore, rule is A will equal my K, which is 3, and B is to power of 2b squared. Example 7. Establish the relationship between the two variables for the given table of values. Now if we look at this one, as x increases, y is decreasing. So this is going to be inversely proportional. So I end up getting y is inversely proportional to 1 divided by x to the power of n. Again, I don't know what that n is, and therefore I get y equals k divided by x to the power of n. And again, I'm going to say let n equal, and I'm going to substitute each point in there and work out my k. So I'll rearrange my k here. I'll get k equals y times x to the power of n. So when n equals 1, I get k equals, the first point is going to be 1 and 30 that I'm putting in. So y, 30 times 1 to the power of 1, so that's 30. Okay. The next point, 3 and 10. Oh, that's a bad 3. And I get k equals y is 10, x is 3. 3 to the power of 1 is still 3, so k equals 30. The next point, 6 and 5. K equals 5 times 6 to the power of 1, so k equals 30. It's looking good so far. 12, 2.5. K will equal 2.5 times 12 to the power of 1, so k equals 30. And the other one, 15 and 2. K will equal 2 times 15, so k equals 30. Again, we can see that all the k's are the same. K equals to 30. And therefore, I get y is proportional to k, which is 30, divided by x. And remember, my n was 1 when it worked for, so I don't need to put x to the power of 1. I'll just leave it like that. Now, to find the specific type of variation that exists, you can use this as a guide. Direct variation, if a is proportional to b to the power of n, then the graph of a against b to the power of n will be a straight line through the origin. The gradient of this line will be the constant of variation k. If it's inverse variation, then the graph will be a straight line not defined at the origin, and the gradient of this line will be a constant variation, which is k. Example 8. It says, for the given table of values, plot the graph of a against b squared, and hence establish the rule relating a to b squared. So right over here, we might as well just put b squared here. Just extend these. So I can quickly work it out. B is 1, 4, 9, 16, 25. Because I have to put a versus b squared. So over here, they're all positive, so you guys will be able to sketch this better than me. A and b squared here. So I'm going to get 1. I better go up by 2s, 4, 6, 8, 10, 12. That's all I'm going to go up by, and then I'll go up by, I'm going to go to a, 12, so I'll go 2, 4, 6, 8, okay, and I'll do one more, 10. So the first one is going to be b squared, which is 1, and a is a half. 4 and a is 2. 9 and a is 4.5. So you see that I actually would get a straight line here. Bad, but I do get a straight line. Okay, and because I get a straight line, I can say that a is proportional to b squared, and therefore a equals kb squared. Now I've got to work out my gradient. That gives me, because that's what k is, that just ends up being my gradient, because this is in the form of y equals mx plus c. The x is just the b squared. So if I work out my gradient, I can take any 2 points, but that's going to be a rise of, if you look at this one, which is 2, and remember this was 1ab squared, sorry, not 2, 4, a is 2. So that's a rise of 2, a run of 4, so that is a half. So k ends up being a half, rise over run. So my rule is a equals a half b squared. Example 9. It says the following data was collected recording the number of calls n made to a company D days after the start of an advertising campaign, and there they are in there. Find a relationship between N and D using a CAS calculator. So we have our data. So we're going to go to our lists and spreadsheets. We're putting our data in there. That data in there is our days, and this data in here is the number of calls. And you can see it's 5, 10, 15 for our days, 50, 400, 13, 50. Then we're going to go to the stats page, okay, and we're going to create a scatter plot, and then we're going to go menu, analyze regression, show the power, and that will give us the rule that we are after. Example 10, using the data in the table, establish a rule connecting Y and X. So again, we do the same thing. Go list and spreadsheets, enter in our data, create our scatter plot, and we get our rule there showing.